Hi everyone, this is Miss Englert. I'm going over the notes for Thursday, December 17th, 2020, and the aim is 4.13, how do erosional processes affect the landscape? So I'm going to go over the notes. Your due now is you need to write down what is the name of this glacial feature. We went over it in our notes yesterday, and then draw the direction the glacier was moving in. So one erosional feature or one erosional agent we're going to talk about is wind. So how does wind move sediments? Wind transports small particles such as silt and clay. It also moves sand as well. Silt and clay over great distances, even halfway across a continent or an entire ocean basin. Particles may be suspended for days. Okay, so if they're suspended, they're held aloft by the wind. There's another process called saltation where they bounce above the ground. So the particle will be lifted, bounce off the ground, be lifted again. Or they creep, which means they're mostly just pushed. Sand, or rather another question, how does wind move sediments? So wind is a stronger erosional force in arid or dry places than it is in humid places. And this is because winds are stronger. In humid areas, water and vegetation bind the soil, so it's harder to pick up. In arid regions, small particles are selectively picked up and transported leaving behind large particles. So a certain depositional feature of wind are called sand dunes. So sand dunes slope gently in the upwind direction. And downwind they have a steeper slip face that forms. So the wind blows, it moves the sand particles up the slope. Once it reaches a certain angle, this is the angle of repose, it collapses and it travels down the side. Then more sand moves and it travels down the side, and it creates these layers called cross-bedding. So for sand dunes to form, there must be an abundant supply or a lot of sand. So there has to be an abundant supply of sand. So a strong wind slows down, often over some type of obstacle such as rock or some vegetation, and it drops its sand and it forms these sand dunes. So another type of particle left behind, or another feature left behind, are called ventifacts. They're moved by the wind through abrasion. And I apologize, we made this slide wrong. So remember, as a grain strikes another grain, it erodes the surface. So stones that have become polished and faceted due to sand particles. So those three words go in the blank. Particles moved by wind do a lot of the work of abrasion. As a grain strikes another grain surface, it erodes that surface. Stones that have become polished and faceted due to abrasion by sand particles. Those are what ventifacts are. So this one I want you to think about. So in the 1930s, several years of drought affected over 100 million acres in the Great Plains from North Dakota to Texas. So for several decades before this drought, farmers had plowed the prairie and loosened the soil. When the soil became extremely dry from lack of rain, strong prairie winds easily removed large amounts of soil from the farms, forming dust storms. This region was called the Dust Bowl. In the spring of 1934, a windstorm lasting a day and a half created a dust cloud nearly 2,000 kilometers long and caused muddy rains in New York State. Identify one human activity that was a major cause of the huge dust storms in the 1930s, and how could this have been prevented? On the next slide, how do waves move sediment? So waves, ocean waves, are energy traveling through water. The largest waves often form from the wind. They form actually when the wind is very strong. And it blows steadily for a long time. And it blows over a very long distance. Wave energy does most of the work of erosion at the shore. Smaller particles are often carried farther out to sea. So most sediments left on beaches are going to be quartz sand. So quartz sand is very, very difficult to erode and break down because it's hard. It has a most hardness of 7. So most sand on the beaches is going to be quartz sand. Something that's formed, or rather, an erosional feature formed by waves are barrier islands. And these are shores that are relatively flat and gently sloping. They may be lined with a long, narrow barrier of islands. Most barrier islands are a few kilometers wide and tens of kilometers long. In its natural state, a barrier island acts as the first line of defense So it acts as the first line of defense against storms such as hurricanes. So that barrier island helps slow down waves, and it also helps break up wind reaching the shore. So you guys can watch this video. It is a video of barrier islands, I believe in New York. Sandbars. Sandbars are an area of sand, gravel, or fine sediment that sits above the water. It may be connected to the shorelines. Sorry, it was written terribly. Connected to the shorelines, or it may be offshore. It is generally narrow and straight. Sandbars begin forming underwater. As waves break, this pulls material from the shoreline, migrating farther into the ocean. So I want you guys to think about it. Should we continue building communities on barrier islands? Why or why not? That is your exit ticket, and that is all that you have for today. All right, guys, so finish up your Pear Deck and go ahead and hit turn in on Classroom.